Good morning, good evening, good afternoon to everyone out there. Once again, I'm very happy to welcome you to the latest episode of the NetOps Expert. And with me today, I'm again very happy to be joined by Shamus McGillicuddy. He is Vice President of Research at EMA, otherwise known as Enterprise Management Associates, the leading IT analyst firm out there for all IT. Shamus, good morning.
Good morning, Jeremy. It's a pleasure to see you again.
Thank you very much. You as well. Can you please tell the audience a little bit about yourself, your career, and then we're going to jump into a really hot topic today.
Yeah, sure. I'm a former journalist. I used to be a newspaper man, but that doesn't pay. So I went into the IT world and did journalism there for a while. And then EMA hired me to take over their network infrastructure and operations practice because that's what I focused on as a journalist, was covering the networking industry. So I do a lot of market research and a lot of consulting and with vendors, helping vendors understand what their customers need. I really, that's what I enjoy doing, is like understanding what enterprise networking professionals are doing and what they're struggling against. So I survey thousands of them a year, well, on a quarterly basis almost, and I talk to dozens and dozens of networking guys in women, both in the large enterprise space on a regular basis about everything from network monitoring to network automation to SD-WAN strategy, and recently I did some research on the experiences that IT people, especially network infrastructure and operations people, are having with AI and machine learning technology and how that can enhance network management. And I surveyed a few hundred people that had some experience with that and talked to some of them one-on-one to get their impressions and like what they're thinking about moving forward.
Yeah, great segue, because today's topic is about AI-driven network monitoring, network management. And you and I have talked about this before. When I was running data centers back in the 90s or 2000s and 2010s, a lot of it was about, set it and forget it, right? You build a router or you build a switch and you just wait weeks, months, even longer for it to break. But as you know as well as I do, network management, network monitoring is finally in the spotlight, but with a lot of complexity. And some of that complexity is our topic today around AI and ML and analytics in network management and monitoring. So why don't I kick it off with the first question? And all this has to do with your research. And we're going to share your research with the listeners here in a webinar that they can hear some of that data firsthand from you. But regarding some of that data, in your report, you say nearly 92% of organizations believe AI and ML-driven network management can lead to better business outcomes. Why do you believe that number is so big? What are some of their use cases? And I got to say, AI and ML and network monitoring sounds pretty scary. So I'm really interested in why 92% of them are so confident about it.
Well, first off, it doesn't have to be scary because you as an IT professional can sort of decide how much you're going to let the AI technology and the machine learning algorithms manage your networks. You can decide whether to accept its insights or reject them. A lot of vendors have capabilities in there where it says, do you think that this was helpful, or do you have confidence in that? And you can click yes or no, and it learns from what you think. But so that 92% figure comes from people who have experience with this stuff. It's not people who are coming off the street and saying, oh, that sounds cool. It's people who have used it or have done extensive evaluation of these features and these products. But if you dive deeper, among that 92%, only 50% strongly agreed with that idea of getting better business outcomes. Another 41% said that they somewhat agreed. So there's some softness under that 91%. The people who were most confident were IT executives and security teams. There's a lot of AI-driven security solutions out there that are using it to find like anomalies and suspicious behavior. So they may have more experience with this stuff delivering value. Most of the survey was network engineering teams people and network operations people, like working in a NOC. And those people were the least enthusiastic. Now, there's still a lot of enthusiasm from that group, But basically what you're seeing is like the people that are working most closely with and most exclusively on networks were the more pessimistic people. So there is a lot of pessimism out there. But like still there are lots. I mean, that 91% figure is hard to ignore. Like there is a recognition that this stuff has value.
Yeah, I know it's today's day and age, we have to accept the fact that hands on keyboards and manually configuring networks today is a task from the past. But it is really hard to give up that hands on keyboards where you're confident that a router config is working appropriately, and God forbid a machine takes over and changes something, or someone else even comes behind you and misconfigures that device. So I can understand the pessimism out there when it comes to some of this. So you mentioned a security use case around anomaly detection. What other use cases out there when it comes to network monitoring and management, especially for the NOC, that you see analytics and AI playing a role in?
So the first example that comes to mind, my mind is like enriched trouble tickets. AI-driven network monitoring tools that can ensure that every alert it sends out that's going to generate a ticket adds automated problem isolation analysis, root cause analysis, in a way often described in natural language. Like, we believe that this event is caused by this, is coming from here, and this is a misconfiguration, or this is a memory issue with this switch. That's something that I think has been really recognized by some of the early users of this stuff, just because alerts and tickets are the bane of a network operations professional's existence. I remember talking to one network engineer at a very large manufacturer who told me that at any given time he has 1,000 tickets open on his network, because he's gotten good at recognizing a critical incident and focusing on that, and he leaves like the other 1,000 to just sit. And if you have tickets that are infused a lot of AI-based, ML-based analysis, it can really allow people to prioritize them and address them more quickly. And also then you get like intelligent escalation too. Either the tool is smart about escalating it automatically to the right subject matter expert, or the tier one people who are opening each ticket and acknowledging it and figuring out what to do with it, or like, oh, I know who to send this to. Another huge use case is just event correlation, which is kind of related to what I was just describing, which is an AI ML based capability can correlate dozens or hundreds of alerts into a single event. And that's what a lot of AIOps products, specialist products do as well, where they can take like hundreds or thousands of events and correlate into like a dozen. You can say, all these events are leading to this, or all these alerts are leading to this one thing. And then when an administrator opens up a dashboard, instead of sorting through those hundreds of alerts and trying to figure out what to focus on, which is another thing that I hear over and over again from people in general, is like the art of figuring out what to focus on when you open up a dashboard that's full of red lights. Instead of sorting through all that, the person is presented with just a handful, with also information on like how much each event is impacting the business and users and applications, so that you can sort of sort them and say, I'm going to fix this one first, and that's actually going to clear 250 alerts and maybe like 20 tickets, right? And then automatically like closes the tickets, and he doesn't have to worry about it anymore. So those are big ones. I mean, some early ones are like just anomaly detection. Like sometimes a vendor will come to me and say, we have AIOps now because we're doing anomaly detection, but they're not doing like anomaly diagnostics. They're just like, I'm really good at finding anomalies, and then I grab all the logs that are related to that anomaly and I send it to you and say, somewhere in these 50 logs is the problem, so go figure it out, right?
Yeah.
So that's like you know, a low-hanging fruit. And then my next question of that vendor is, well, when are you going to find that problem for them in those logs and just send that to them and say, if you do this, it'll fix it? And they're like, oh, that'll be in 12 months. Yeah.
Exactly. You know, it's really great to hear about that low-hanging fruit use cases that you're talking about, like automated ticket generation and insertion of root cause analysis, the event correlation or suppression of events behind what, you know, the solution believes is that root cause device. And you also mentioned AIOps, which is actually leading us to our next question. From your research, I have most organizations apply AI and ML and AIOps to network management via their network management vendors. Domain agnostic AIOps products are less popular for network management use cases. And listen, you and I know when AIOps was the bee's knees, so to say, just a couple years ago, and it was going to solve the world's problems. But now, you know, some of the research that you're mentioning says that the analytics should be in the network management vendor solution, not especially in the overall AIOps solution, which is covering app, infra, and network. Can you explain that?
Yeah, so I remember having a conversation for this research with a network operations network engineer, and I was asking him, like, what kind of AI is the organization using? And he said they were using a general purpose domain agnostic AIOps tool, and he was sending his data from his monitoring tools into it. And so the value there was event management. Like, that tool was figuring out where the problem is. Is it the network? Is it AWS? Is it like your virtualization environment? Whatever, storage. And that's good for like automating like tier 1 response, right? But if you want to automate tier 2, tier 3, where you dive into the networking stack and try to figure out, you know, where the problem is and how to fix it, like a lot of general domain agnostic AIOps platforms don't do that. They're not domain experts. They're domain agnostic. They're finding the problem. They're managing like a ticketing and escalation and stuff like that. But then they leave it to network engineers to figure out the network problems. And so there's this recognition that if you're looking to dive deeper into applying AI and machine learning to network operations, you're better off going with a vendor that has a lot of domain expertise, like your network management vendor or your network infrastructure vendor. I mean, that's just the way it is. Like, networks are not simple, you know. Networks are probably the most complex domain of IT, in my opinion. That's why there's so many problems in network management remain unsolved.
Is that why, or do you see that same complexity in the app and infra areas of AIOps, where they can only dive so deep and then have to hand it over to an expert?
To some extent, but when you look at it, like some of the vendors that like have been classified as AIOps specialists are very focused on like DevOps and cloud and application performance management. So, but yeah, there's, I think there that like hybrid multi-cloud application environments probably have a lot of complexity, right? And there's, you know, anywhere where there's new technology is going to have complexity. So like cloud native application platforms, like there's a lot of innovation around observability of like Kubernetes and stuff like that to address some of the lost visibility there. So that might be a layer of complexity. But something like storage, like there's not a lot of complexity there. Compute, I mean, that's just, there's a reason why certain markets or industries in the IT world are highly commoditized, like servers, and it's because it's not that complex. But in a network, like every single device in a network is doing its own thing. Like it's herding cats. There's like every switch, every router, every firewall, even like something that has a central control, like an access point, like they do their own thing. They're making independent decisions about where to send traffic and how to recognize traffic and how to apply policy and things like that. You don't see that layer of complexity in other parts of IT usually. And that's why I think AI and machine learning has to come from a vendor that's got networking expertise.
I'm glad to hear you say that, of course. Not that this is a plug, but Broadcom and our network management solution has that 3 decades of experience, especially around the algorithms we've written into our fault management solutions around root cause analysis and event correlation, and anomaly detection, et cetera, capacity planning. But I know you agree with me on this because you're talking about all these great use cases and what these AI and algorithms can do for level 1 NOC operations. But I'm sure you'll agree that with any solution, especially AIOps solution, garbage in, garbage out, right? So what kind of data is needed to be collected in order to be successful with some of those use cases? Because like you said, networks are complex and there's a large amount of data out there to collect, but collecting the right data for insightful and intelligent results and surfacing of that root cause is so important. So what's the data behind all this magic that is needed to be successful?
Network operations teams are collecting more data than ever before. I think this is just a never-ending reality that the volume of data they're collecting and the variety of data they're collecting is constantly expanding. That's what my research shows. So, and I think data quality becomes a major issue because a lot of network operations teams use multiple tools, and the data between those tools isn't always consistent. Like it might be something like, time data collection intervals, and matching that up. But also some tools have lots of errors when they're collecting, and they have gaps, and others do not. But so the data that is important is it's so hard to answer that question because it starts with like device metrics that you might collect through SNMP and ibs and traps, but also maybe just directly through device APIs, or maybe even better, streaming telemetry, which is the most granular and reliable, but still like emerging for a lot of people who are on the adoption life cycle. But then there's flows, like network flows, whether it's NetFlow, IPFix, SFlow, whatever. That is also valuable. If you have the resources, like packet data and packet metadata can be of value, but that's an expensive proposition for many, and not every. And chances are, if you are using it, you've got a vendor who's doing a lot of investment in AI ML right now anyway. And then DNS records, like queries and response data, especially if you're applying AI and machine learning to security use cases, can be really important. Increasingly with like work from home and multi-cloud and software as a service adoption and things like that, it becomes really important to have active synthetic network data that you inject into your environment in places where you don't own the infrastructure, like a work from home environment, so that you can get better visibility into end user experience and cloud application experience and things like that. And then in logs are, most like AIOps specialists domain agnostic vendors will tell you, well, logs are, the
Holy
currency.
grail.
Yeah. The machine data tells you all, so there's that. So syslog, whatever from your network infrastructure can be very valuable. Topology data, if you have a tool that analyzes and produces topology data, configuration data. Really, a lot of the answer to that question is driven by use cases and like what use cases you focus on or your vendors focus on. So there's no end. It's really depends on like looking at the solution that you're thinking of adopting and what data they are capable of collecting, processing, analyzing, training their algorithms on, and going from there. But before you start to adopt AI and ML solutions for network management, it's important to think about the data you have, that you're like what you collect now, and how reliable your data collection is. If you have a lot of errors when you're collecting data, you want to clean that up before you start using AI. Because when you adopt this technology, your vendor is going to tell you that the algorithms need to learn your network, and train themselves on your network for a period of time. It might be like a week or something. And if your data quality is suspect, it's going to limit the value you can get out of the technology.
Garbage in, garbage out. Yeah, and talking about data collection across multiple vendors, like you said, network devices are kind of doing their own thing in their own little world. They speak their own language. So imagine herding the network cats and none of them speak the same language and they're all going in different directions. Besides collecting all that data, it needs to be correlated and needs to be normalized and cleaned. And then finally, after all this data has been speaking a dozen different languages, it needs to be surfaced in a language that can be read and understood easily by a level 1 NOC operator. So, a Wizard of Oz analogy, every vendor claims their Oz out there, including Broadcom. But what's the guy behind the curtain doing? What levers is he pulling? And is he doing it the most intelligent way? And what information is he gathering to show and surface? I think that's where the expertise lies, is, what's happening behind the curtain. I will say this, and I think I may have said it on a previous episode with you, but a very good friend of mine who works at a large bank here on the East Coast. He's the lead network engineer. I saw him the other night and we're talking shop, and he says, the engineer/architect is way too busy. He should not be dealing with an issue unless it's been proven by the NOC that it is an issue and that it is his issue and no one else's. The NOC is not doing their job if that isn't the case. Now, you and I have talked about a lot of different topics, but I believe all those topics lead to that epiphany, right? The NOC should be able to be very intelligent and insightful into whether they're going to fix the issue or escalate the issue, and you better damn well have the data to prove that I need to stop what I'm doing and work on it if you could have fixed it to begin with. So, Shamus, I want to thank you for your time today. And again, to our listeners and viewers out there, please check the show notes for the latest research that Shamus did on this topic and the webinar link where he presented this data out there last year. Shamus, any final words before we sign off today?
Yeah, just responding to the last thing you said about that network engineer friend of yours. I immediately remembered a conversation I had with a network engineer at a Fortune 500 company who told me that too many companies don't invest in the NOC, that they don't do enough to train their tier 1 technicians in the NOC, their analysts and whatnot, so that they can know that fundamental question of who to send it to and whether it's a problem or not. So it's like an endless cycle, The tier 2, tier 3 guys are like, why am I getting this? And the tier 1 guys are like, I don't know how to do this.
Exactly.
and AI and machine learning could help address some of that. And it's I'm seeing some of that happen. So it's good.
Well, that's great to hear. As you know, and I know, Broadcom builds its solutions first and foremost for the level 1 NOC operator to get done as much as he can without escalating. So we're very proud of that fact, and I'm glad to hear you say that. Shamus, once again, thank you for joining me on the NetOps Expert. I always appreciate the conversation and the insightful data that you give out there to our audience. Once again, I want to thank everyone for listening, and please stay tuned for the next episode of the NetOps Expert.